Okay, so socket programming is where we're going to be writing software. We're going to be writing software that allows our computer to talk to another computer. So you can read this when you get a chance or look through it in the slides. But the idea of what a network socket is, a socket is the combination of your IP address and then an extra number on your computer, which actually corresponds to the application that's running on your computer. They typically call it a port number, but they probably should have called it an application number. I've been calling it a port number for years, but so the port number is kind of like if you've ever called a phone number, like here at the university, and then you ask for an extension, you know, so-and-so on that extension. So there's a phone number and then a particular number inside the university. Okay. There's going to be two pretty common types of protocols. One is connection-oriented and one is non-connection-oriented. So that would be if you're sending a message to a computer and you're not interested in getting a reply, you don't even care if they received it or not, you're just sending it to them. And another type of connection is like when you log into Facebook and you type in your password and they say, yes, welcome, how you doing? And then you say, I want this picture, and then they send you the picture and you're going back and forth. So that's a connection-oriented type of connection between two computers. So, yeah, again, we'll cover the different types of transmissions back and forth in another talk. This is more just like getting the connection started. So, so some famous port numbers that you've probably used before would be like, for example, port number 21 is for transferring files back and forth. So have you guys used FTP? Do you log into the university and get files, or? Okay, so I mean, you've used the web browser. Use the web browser where you type http:// and then some, www.facebook.com, and then that connects you to Facebook. Well, they would be connecting on port 80, which Facebook will actually turn around and they want you to log in through a secure port. So they'll turn around and make it port 443 on their server. But you're basically saying, I would like to connect to the IP address for Facebook, and I would like to connect to them on a certain port number. And they have a process that is receiving that message and reacts to it. So, so these are some system port numbers. I guess the original design was that the port number field is 16 bits long. So with 16 bits we can do, 10 bits is 1K, 16 bits would be 64K, which is like 65,000 different port numbers or so. And it was originally designed that the first 1,000 would be for the first K. 1024 would be for the operating system, and then all the other ones available for us to do socket programming with. But there's a lot more system services now, so it goes into the 4,000 or 5,000 numbers for systems port numbers. Okay, so a socket pair, two computers talking to each other, is defined as a four-tuple, which is the source IP address and the source port number, and the destination IP address and the destination port number. So two different machines, each having their own IP address on the internet, and then two processes running on those two machines, each having their own port number, are communicating back and forth. So that would be called a socket pair. So the operating systems, whether it's Windows or Linux, whichever system you're running on, is going to have a collection of system calls that you as a programmer can call. And we're going to do different tasks along the way. And I guess really what we want to talk about today is what is the task we're trying to do, not so much memorize what is the name of the system call. So for example, on the server side, what we're going to do, and it might be, let me just go ahead a little bit and say, remember when we were talking about process states? What we're going to be doing, let's say you wanted to create an HTTP server, a process that's running on your machine so that somebody else could ask for a web page and you will respond to them. So what we're going to have to do is we're going to have to create a process on our machine, let's say HTTP, and we're gonna have it waiting. We don't want it running on the processor, taking up time, saying, does anyone want a web page? Oh, no, they don't. Okay, well, how about now? Does anyone want one now? No, they don't. We don't want to do that. So maybe we'll have a process that's just accepting all messages that come in, and if there happens to be a message for us, they would write that message to a buffer that we can read from, and then they would send us, like we talked about the V function, you know, they would wake us up, so we would get moved over to the ready queue and start processing and read the message that they put in our buffer. So we're gonna have to do a couple of things. One is we're gonna have to create a buffer for messages to come to so that we can read from it. And we're maybe gonna have to set up a semaphore that we could wait on, so the process that is reading messages coming in could wake us up and tell us, hey, I just put a message in your buffer, why don't you go read it? So in order to do that, we break this down into different steps. So on the server side, a couple of the steps, and nobody says this is the right way to do it. This has been done like this for about 20 years, and maybe there'll be an improved way of doing it. But we have a system called socket, and what the socket does is basically associates a name of a process that we're running to a file or a buffer that data could be read from. We could write to and read from. Then what we need to do, if we're on the server side, is we have to pick an IP address that is available on our system, and then associate that port number to this buffer, or really to this socket. So the socket is just a name and a buffer to write to. So we call socket, and we create, we'll call it creating a socket. Then we call it another function that gets us an available port number and assigns it to our socket. So we're binding a port number, which we're calling an address here, but it's the port number on our server machine, to this socket. Then what we need to do is tell the system, make them aware of us, that messages will be coming in to us. So if a message comes in to us, they should write it to our buffer. And then also they're going to need to wake us up, but that'll be done on a separate step. So when we do a listen, we're saying that this socket that we've created, and we've binded to a port number, is now one of the processes on this server that is accepting messages. So that's what we're doing by saying listen. And then if we call the accept, this is really like a function very similar to the Dijkstra's P function, where you ask, is this resource available? And if it's not, you're taken off the processor and you wait for it. You have to wait for another process to wake you up. So this would be the socket version of Dijkstra's P function. So this is the one where we'll actually get stuck waiting. If you're on the client side, you're going to do the same thing. You're going to create a socket, so it's a buffer to receive data into. But when you're the client, you know the machine and the port number that you're trying to connect to. So when you bring up a web browser and you say HTTP www.facebook.com and hit enter, you're actually building a message. You say, I know the IP address and the port number I'm going to. Because you said HTTP, so that means port 80. And you said www.facebook.com, and that got translated into an IP address. So you're actually doing a connect because you know exactly who you're connecting to. And you'll be passing your IP address and the port number for them to reply to. And then once you connect to them, you could use, depending on the system, sometimes they're called read and write or send and receive. But the idea of reading and writing back to your buffer once you're connected. So from the server point of view, the server does a socket, binds the IP address and port number to that socket, does a listen, which is telling the server, I'm a process that is accepting messages. Any messages come to me should get routed to my buffer. And then it goes to sleep and says, okay, wake me up in the event a message comes in. A client could later on come along, do a socket and do a connect, and they would have to say, connect to this particular machine on this particular port. The message gets sent to the listen, which routes it to the buffer that this process is waiting for, and then wakes this process up. So the process wakes up, it could then send some data, which this thing then receives, and then this thing can send some data back, and we could do, this thing can kind of go for a while, and then both of them do a close, which closes out their respective two sockets. Okay, so yeah, so this is just kind of an internal diagram of what the operating system is doing. So at this point, we have our ready queue. Our ready queue points to process control blocks of programs that are currently running on our system. So let's say we have some other processes that are running, and then we have a servers process, a process that's basically taking all the messages coming in through the yellow cable that goes into your back of your computer. All the messages coming in from the internet and says, oh, this message is an HTTP message, the port is 80. So do I have a process that is listening for port 80? And if some process has registered by issuing a listen, then it would be in the list of all the possible messages we could route to. So if we have a message come into port 80, and there's a process on our system for HTTP, which is the name for port 80. This is waiting for messages to come in. So what we'd have to do is we would take the message that comes in, write it to the buffer that this process is going to read from, and then issue what Dijkstra called the V function, the function that says, hey, wake up, and have this process be added to the list of ready queues, so this could start running, read from the buffer, handle the message, maybe write a message back, and then go back to sleep. So when the server process writes the incoming message to our buffer, then issues what's equivalent to the V function, we're no longer waiting on the HTTP queue. We are now one of the running processes on the computer. So it could be that we run, so the ready queue points to all the processes that are ready. They're all linked together in a cycle. This one points to this one, which points to this one. What's highlighted in red is the process that's currently running. It could take a while. It could, these could run in a round robin manner until this finally served up the web page that came in. And then once it serves up the web page, it goes back to sleep. And it's now waiting for another web page to come in. Okay. So the socket command has three input values, and really what we're doing with the socket, once again, we're just saying we're establishing the type of socket that it is, and we are associating a buffer. So sometimes it's referred to as a file. A file doesn't necessarily mean it's a file on the disk drive. It could be a file in your main memory, and it could be written back and forth between main memory and the disk. Then when you're doing the bind, you're passing in the socket's file identifier that you got from the previous step. And then you're giving an address and a length of a chunk of storage that represents data about what was in the socket. So at this point, the bind will attach a port number to this file, to this socket. And then in the listen command, you're passing in again the identifier for the socket. And also you could give a number of how many processes can at one time be connected to this port. So you could say I'm allowed a backlog or a queue of 10 processes. And then after that, the operating system shouldn't allow any more. So again, when you're listening, you're basically, when you say listen, and you have a binded socket with a port number, you're basically alerting the system that if any messages come in on this port number, it belongs to this socket. And then in the accept state is where you are actually putting yourself to sleep and waiting for a message to come in. And then the accept state would have storage that comes in, so the message coming in from the client, we would pass information in for the accept. So an example of how to do this in C or C++, we would include the system socket.h header file. And the syntax is we would have an integer and we'd call socket and say the type of domain, the domain, the type, and the protocol. So here's an example of how you would use that. And the bind would be, you're actually taking the socket that we got from the previous step and the field that's coming in. So an example of doing that would be like our listen, we call the last step, we call it the listen file identifier. And then we're passing in the server address and the size of the server address block with information about the port number. And then from the client point of view, this is an example of how we would do a connect. So this is where we'd have to have the socket ID and the block of storage that tells us what the port number is and the IP address that we're trying to connect to. And then on the server side, if we did a listen, so this is an example where we're saying we're taking the listen file identifier, which is really the socket in this example. It has been binded to a port number, and we're saying we're allowed up to 10 connections. Can come in and can queue up for that service. And then it's typical, like we've done this in the past, where when you do the function that is equivalent to Dijkstra's P function. So remember, Dijkstra's P function was, if the semaphore value equals 0, you wait. Waiting means you don't put on the processor until some other process wakes you up and says, okay, we're going to move you over to the ready queue, and your process would start running. So if we were going to wait for something, and then when we wake up, that means somebody came into, a message came into us, we might write something back to the buffer and then go back to sleep again. So it's typical that we would always do like a while true or while one, and just keep doing that over and over and over. If we're a server, we would want to stay alive forever. So the code typically shows up in a loop like this. But here's where we're basically doing the except, which is where we are putting ourselves to sleep and waiting for the next message to come in. So all the messages coming in to that port number keep getting written to this structure, and then we go asleep, and then the main processor wakes us up every time a message has come into us, and we handle the message and move on. And then I just started, I know this isn't really about coding, but it would just be kind of good to see what it looks like in code. So again, this is an example in C or C++ of some socket code. So we're taking an integer s, we're calling socket, and then we're binding the socket that we got to a port number, and then we're doing this is actually, connect would be on the client side and listen would be on the server side. So kind of mixing the two together. And then we're writing data. So the writing could be client or server side. And then, and the idea, again, this isn't like a coding lecture, I was just giving examples of coding. But so for example, the system calls, socket, bind, which is where we're putting a port number to a socket. A programming language could come along and come up with different names for these functions, right? So they could make their own function and then call the system function in their function. So different programming languages could do it a little bit differently, but here's an example where we are given a number in our parameters, a number for the port. So we have the port number equals the argument that came in, we pass the argument. And then what might be a good idea is if we used exception handling for the different steps of connecting. So because these different steps may not happen, right? So when you do a socket, effectively what are we doing when we do a socket? We're getting a file a buffer that we can read and write storage to, and connecting it to a socket. So what if our system happens to be out of storage at the moment? And you do a socket and it fails. Well, you can't then do a bind, because there's nothing to bind the file to. The file doesn't exist. So it might be good to put that in a try block, get your socket. If the socket doesn't work, maybe you have a backup plan. Maybe move to another machine and get a socket on that machine. So you'll see socket code has lots of exception handlings to it. So then what we could do is, and I hope this comes out, I hope this code isn't so small it doesn't come out, but just here's an example of Java code where we're using Java system calls. So, for example, we have a type in Java called socket, whereas in C and C++ it ended up being an integer. So in Java we have a type called socket, and we call it client, and we call the constructor for a socket, which is supplied by Java programming language. And we have the server name, and it'll find the IP address for it, and the port number we're interested in connecting to. And then we could print that, I'm just connected to, and then these are functions that will tell us the IP address and port number of the remote system. Then what we could do is we could say get the, again, these are now Java functions that are obviously calling the system functions like read and write. And then maybe displaying the data better for us. So when you go to write, Java has a write UTF, that's the unified, what does UTF stand for? Unified well, it's the way of unified systems to transmit characters to each other. So anyway, so it could say hello from, and then the client, we get the socket address, our local address, which is our IP address and the port number that we happen to be using, and we're sending a message to the server. So really all I'm demonstrating here is that a programming language, you can have an operating system that has all the socket system calls on it, and then your programming language could have its own function calls, which are then interacting with the system calls. So I guess really what I'm saying is you don't really have to memorize, you don't have to memorize these, let's say these are the system calls on a Linux system. Maybe Windows has the same idea, but maybe a slightly different name. But when you go to use a programming language, the programming language could put wrapper functions around them. So, like Java could add get remote socket address of a client object. And then it'll go and read the data from those data blocks. So it makes it a little bit easier for you. You don't have to follow the data, the storage of these structures that are passed in. You don't have to go and know what the structure is and go reading through them. There are functions that will return that data for you. Okay. So in so server code in Java, we could say, we have a greeting server. So now the other thing is we might want to run this as multi-threaded programming. So multi-threaded programming, just as a reminder, is where you can have a process that has children programs, and when your process gets put on the processor, you can let your children processes run independent of each other and share your time. So in this case, again, we have a port number, gets passed into us, and then we're going to say we're going to get the server socket for that particular port, and that's going to become our server socket. And then we can also have a timeout. Timeouts are in milliseconds, so that would be like a 10-second timeout. And then we could have exception handling. So we could handle the case where a socket timed out, and we could do whatever we need to do, maybe give it more time, or maybe do some kind of diagnosis, why is it timing out. And then we could also have I/O exceptions. input-output's not coming in correctly, so we want to handle exceptions like that. So in Java, if you wanted to run code on a separate thread, does this come up in your Java class, in multi-threaded programming?
Yeah.
Okay, do you remember the way Java did it? It kind of was cleaner than in C++. In your class, there's a function with a special name called run. Any method you have called run, the code in that method has the ability to run on a separate thread. Do you remember what you had to do to make it run on a separate thread, not your own thread? If you called it by its name run, it would run on your thread, you being the parent process. But if you called it with the method start, S-T-A-R-T, what it'll do is start will create a separate thread, and then it'll go looking for a method called run and run that code on a separate thread. So in this case, we're coding it up as run, and then we're going to later call this by using start, not run. So again, this is like while true, meaning this is going to loop forever. And we're going to say, okay, so this is server code. It's going to say I'm waiting for client on port, and then we get the port number. So that's our port number on the server. And then we have, we do an accept. So by doing an accept, so this is now the Java accept. So we're actually taking a server socket called server of type socket, and we're saying server socket.accept, which is obviously calling the system call for accept. So this is where we're going to go to sleep, and if a message comes in to us, because we did a listen previously to this, the message coming into us will be written into our buffer, and then the operating system will wake us up to move our process, this thread, over to the ready queue so the ready queue can run. So then we'll say, okay, now we're connected to, and we'll get the address we're connecting to. And then we can write to them, thank you for connecting to us. We'll give them our IP address, and then we say goodbye, and then we close. And we could do that over and over and over. So really all I'm getting across here is that your operating system, whether it's Linux or Windows or whatever your operating system is, if it is an operating system that allows socket programming, which just about everyone does, you would create a way, you would have to create a way to do the different steps needed to communicate to another machine. And it's possible that your programming language could make functions that are actually calling the system calls for you. So you don't want to have to memorize the functions, you more want to know what each of the tasks are, and then figure out in your programming language, how do I do those tasks? So running this separate thread, we would be passed in a port number, and then in a try block, we might say create a thread called reading server with that port number. And then we would call that thread's start method, and the start method actually calls the run method running on a separate thread. Anything goes wrong with that, we catch an exception and print out what the error was. Okay. So yeah, so that's really, I mean, like I said, I didn't want to focus too heavily on the code, I just wanted to give some coding examples. Try to make it as simple as possible to just get the point across. We're waiting for a message to come in, we say thanks for the message, goodbye. And then it would be our choice if we wanted to, we could set up a server process. So really the main difference between a server process and a client process is a server process runs on its own machine and then sits there waiting for someone to connect to it. A client actually has to know who they're connecting to and what port number, send a message to them, and be ready to receive a result. We can have a conversation between a client and server that goes back and forth until they both agree to let it end. We could also have a message, we could send a message that just says, I want to send you a message. I don't care if you receive it or not. Here's the message, and maybe you receive it, maybe you don't reply to me. So there's different types of combinations different types of ways of having conversations. And I guess we'll talk about that the next time, the different types of conversations. Do we want to have stream conversations, and do we want to have connection oriented? I'm connecting to you and we'll stay connected to each other until we mutually agree we're finished, or do you just want to broadcast messages out? So those will be added. How to do that will be added to the message. So we'll be not only sending a message, we might be saying, and if you want to reply to me, here's the instructions on how to reply to me. So it's kind of like in the mail. If you send mail to somebody, you could write a letter to somebody, put it in the mailbox, and who knows, maybe they get it, maybe they don't. Or you can send them a bill and put an envelope inside and say, pay this money, and then they put the money in and they mail it back to you. You give them instructions on how to get back to you. So there's two different types of communications, and yeah, we'll go over those next. So any questions about the different system steps that we need to do? So you might think, why don't we just have this one big step? Like, in other words, we want to tell our system, let's say you downloaded XAMPP, and you bring up the dashboard, and the dashboard says you can start the MySQL server, you can start the Apache, which is the HTTP server, you can start PHP. Do you have to start the PHP? Is there a button to start that? Okay. So that's a separate process. Any other processes you have to start up? Okay. So the question is, once you start up the process, so when you hit that button, Start Apache, what you're really doing is socket, bind, listen, and accept. You're doing all four by hitting that one button, right? So you're right, because now, as soon as you hit Start Apache, your machine, if a message comes in on port 80, your machine is going to pick it up and route it to your process. So with one button, you're doing 4 steps. So you might think, why do we have 4 separate calls if everybody wants to do all 4? Well, you'd be a server in that case. If you wanted to talk to somebody else, you'd be doing something different. So it's broken down into different steps, and then, like I say, with the XAMPP, in one button, you hit the one button, it does 4 system calls for you. And it's probably handling exceptions too, if anything went wrong. Have you ever gotten anything go wrong and it can't start? Have you used that? You ever start Apache and it says there's some problem? Okay. So if anyone, I'm sure the way it's coded, it's trying each one and then handling exceptions along the way. If anything goes wrong, it'll tell you what's wrong and maybe even ask you, how would you like to solve it? Right, so the idea is, why have it in different steps? Socket and bind and listen and accept. Why not just have one button for the whole thing? But there are different combinations of things we could do, so that's really the answer for that one. But any other, actually here's an example where MySQL is running. So if you're starting XAMPP and you hit the MySQL button, you're notifying the server process that you're accepting messages. You have a process that's waiting for a message to come in. Any message that comes in for the MySQL server gets written to your buffer. This process should wake up this process so that this one can now come and pick up the SQL statement, issue it, and return the reply. Okay, is any other questions about this? So again, this was like a high level, and then maybe we could look at socket code for a particular language, but it would be using these ideas.